Okay, so today we're going to talk about trigonometric functions of angles. This is section 5.3, and the main idea I need to talk about today is something called reference angles. So far we have dealt with triangles, and so the angles we have dealt with have all been less than 90 degrees. So for example, here is a triangle. Definitely theta is an acute angle. It's less than 90 degrees. So for this particular problem, and I'm going to call my hypotenuse, I'm going to call it R. I'm going to explain why in just a minute. But if I were going to do sine theta, then I would take opposite, which would be y, over my R, the hypotenuse, and I could come up with what that expression is. Here this is in a circle. And here's my triangle, and here's my angle theta. So the reason why I labeled this triangle an X here, because I have this set up where my angle is measured in standard position, which means it starts on the positive x-axis. So that means this distance is x right here. Along this base part of the triangle, the distance is x. This would be a distance of y. So for example, I could call this point right here, this point has the coordinates x, y, because this is 0, 0. My center of my circle is 0, 0. So I'm going over x and up y, so that would put me at the point x, y. And I could say sine theta equal, and that's why I'm calling this r, because it's the radius of my circle. So sine theta would be equal to y over r, which is kind of what I drew here. But what happens if my angle I want to know about looks like this instead? What if this is my angle? And I want to know the value, I want to know sine of, I'm going to give this a different letter. I'm going to call this alpha. And suppose I want to know sine alpha. Well, alpha is, actually, I'll just tell you, alpha is 150 degrees. Okay, so I'm drawing this to be 150 degrees, and I want to know what sine of, actually I might change that, hold on. Actually, I'm going to leave that, but I want to talk about what theta is. I'm going to let theta be a 30-degree angle, and then we know if it is a 30-degree angle, that's a special triangle. So remember, it's 1, 2, square root of 3. So sine 30 degrees is opposite over hypotenuse, so it's 1/2. So I want to use that as an example. This would work with any, but I just want to show you. So then I'm letting alpha equal 150. So if this equals 150, then notice that I have this other little angle right here. And I can think of a triangle. I'm going to draw a triangle like this. But this time, so notice the symmetry here. It looks like the triangle's just been flipped into the second quadrant of my graph. So if this that I labeled alpha is 150 degrees, and we know that the straight angle is 180 degrees, then this little piece right here would also have to be 30 degrees. So this little piece right here is the same size piece as this over here, as my theta is the same size piece, it's 30 degrees. However, notice that my x value is in the opposite, it's negative here because I'm going to the left. So I can kind of think of this as a negative value. So I'm going to call this negative, x is negative, but I'm going to call it negative x. And then here we would have y. So this time, if I were going to evaluate this, and here's the really cool thing, we can use the triangle that I just drew, and we can think of it as y over r, because this is r, this is the same thing. So if I wanted to know sine of 150 degrees, it's the same as sine 30 degrees, except that because my x value was going to the left and it's negative, so I would have a negative, oops, no, actually, let me rephrase that. The x doesn't matter for sine because remember it is the y over r. So we would be taking y over r, so it's a positive value over a positive value. So sine of 50 and sine of 30 are both equal to 1/2. So it's the same value. You can check that really easily if you look at your calculator. If you put in sine of 30 degrees, make sure if you hit mode that you are in degrees if you don't get a 0.5 or a half. And sine of 150 degrees is also 0.5. So we see that. Now, next thing I want to show you is what if my angle instead was right here, and I starting in standard position, because you're always starting in standard position, so it's what I'm tracing out in green. So let's think about what that would be. That's 180 degrees plus 30 more. So now I'm talking about, I'm going to use the symbol for beta. It looks like a B. You start at the bottom and make kind of a fancy B. And so then I could say that sine, I'm looking for what is sine of beta. So now you might be able to see what I'm going to do. I'm going to be using this triangle instead. So I'm still, this little piece right here would be 30. So I'm still using a 30, 60, 90 triangle. It's just, notice the reflection, it's reflected. So this time, if I want to do sine, I'm going to take the opposite. I'm going to take the y value, but notice this time my y value is negative because I'm going down. And so the y value is negative. So what's going to happen is it's still going to be opposite over hypotenuse. So if this is, if I thought of this as, let's say 1, 2, and square root of 3 for my triangle, then I'm still going to have 1 over 2, but because this value, the y value is negative because it's going down, so I'm going to get negative 1/2. So this would be sine of 180 plus 30, so sine of 210. And you can check this on your calculator. If you do sine of 210, you see you get negative 1/2. So let's do, we have one more. What if it were this way? And here's my triangle. So this time, here's my angle. I'm going to call this theta because it's the same size as this one up here. And this time, because when I take my y value is negative, and then I have my r value. The radius, this is the radius of a circle, so we're always going to consider that to be a positive value. So it's only the x and the y that can sometimes take on a negative value. So, this, in this case, it would be, I'm going to think of it as 360 degrees minus 30, because what we're looking at is we're actually looking at this angle all the way around. But I'm going to use this angle to help me. So this is actually going to be sine of 330 degrees, since I'm letting theta be 30. So if I do sine of 330, and again, y is negative, so I'm going to get a negative 1/2 when we do sine of 330, and you see we get negative 1/2. So here's the idea. If you want to find a trig value of an angle that's bigger than 90 degrees, you have to find what's called the reference angle. And to find the reference angle, actually I'm going to use a definition that's in your textbook for reference angle that says let theta be an angle in standard position. Remember what that means. It means that the initial side is on the positive x-axis. The reference angle and they call it theta with a line over it. I'm going to call it theta with, I'm going to call it theta prime. That little symbol I'm going to say is prime. It's kind of just what I'm used to. The reference angle theta prime is the acute angle formed by the terminal side of theta and the x-axis. Doesn't have to be the positive x-axis, just the x-axis. So you might want to pause the video, write that down so you have that in your notes, and then we'll go on and talk about that, and I'll show you some examples. So suppose this is my angle theta, and I wanted to know what's the reference angle. Well, the reference angle is the acute angle that's formed by the terminal side. This is the terminal side here, the terminal side and the x-axis. So my theta prime would be in this spot right here. So if this was theta, this would be theta prime. Okay, so now suppose my angle is like this, and suppose this is theta. Theta prime, remember, is the terminal side, which is this side here. Standard, the initial side's always positive x-axis. So the terminal side to the x-axis, so I'm going to go this way, that would be theta prime, whatever size piece that would be. So note, and we'll talk about that in just a second. Now suppose I have an angle that's like, oops, there's my initial side, and let's suppose it's like this, where it goes all the way around here to the fourth quadrant. So that's my angle. So if this is theta, then theta prime is the part, it has to be an acute angle. So this would be theta prime. And the one that I didn't do, I probably should have done first. If this is the angle, and if this is theta, then it's also theta prime, because that is the acute angle. So the quadrant 1 angles is no big deal. Now this was quadrant 1. Up here I have quadrant 2. My angle's in quadrant 2 because that's, let me put this in the right place. So quadrant 2 is here. This would be a quadrant 3 angle because the terminal side is in quadrant 3. And this would be a quadrant 4 angle because the terminal side is in quadrant 4. Remember, this is the x-axis and the y-axis, and so we have our 4 quadrants. So that kind of gives you an idea of the reference angles. Now, how do you find that? Well, suppose theta, remember this is 0, this is 180. So if I had a quadrant 2 angle, maybe say 135. So suppose theta was 135 and I wanted to know the reference angle. Well, I'm going to take 180 and subtract the 135 and see what's left, and that would be the piece here. So I would take whatever I would take to find the reference angle. I would take the straight angle, 180, and I would subtract theta, and that will tell me what my reference angle is. That's if it's a quadrant 2 angle. If it's a quadrant 3 angle, notice that if I want to know what theta prime is, I have to take theta and subtract the straight angle to see what I have left. So I would be taking theta minus 180. So it's different each time depending on the quadrant. Down here, I would be taking, I think what I would do on this one is I would take, to get theta prime, I'm going to take 360, which is the whole circle, and I would subtract theta, and what I have left would be theta prime. Okay, so that would tell you what that piece is. Here I don't have to worry about it because whatever theta is, that's the same as theta prime. So it's really important that you understand that. The other thing that we have to think about is where x and y are positive and where they're negative. So when okay, so let me go back to this and build a little triangle here. I'm going to call this theta, and remember we called this x and this y and this r. So if I'm in quadrant 1, then and this point right here is xy. And when I'm in quadrant 1, x is positive and y is positive. In quadrant 1. In quadrant 2, then we know that x is negative, but y is positive, right? Because if I'm going to the left, so all the x values are negative, the y values are positive. In quadrant 3, x is negative and y is also negative because I'm going to the left, which is negative, and down, which is negative. And in quadrant 4, x is positive, but y is negative, because I'm going to the right, which is positive, down, which is negative. Now, going back to our triangle, sine theta equals opposite, which is y, over r. And remember, r is the radius. It's always going to be considered positive. Cosine theta is adjacent over r. Tangent theta is opposite over adjacent, so it would be y over x. Now, in the different quadrants, suppose for sine theta, since r is always positive, then sine theta is going to be positive whenever y is positive. So y is positive in quadrants 1 and 2. So in quadrants 1 and 2, sine is positive. Let's see how I could write this. I'm going to make a little chart. So in quadrant 1, y is positive, r is always positive, so sine is positive. In quadrant 2, y is positive, so sine is positive. In quadrant 3 and 4, sine will be negative because y is negative. For cosine, cosine is going to be positive when x is positive. So in quadrant 1, it's positive, but in quadrant 2, x is negative. In quadrant 3, x is negative, and in quadrant 4, x is positive, so cosine will be positive. Tangent is going to be positive when both y and x are positive. So in quadrant 1, they're both positive. But in quadrant 2, one of them's positive, one's negative, so we get a negative result. In quadrant 3, they're both negative, and a negative divided by a negative is a positive. And in quadrant 4, one of them is negative and one positive, so we get this. So one of the things, notice that all of them are positive in quadrant 1. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. So this is where they're positive. So just remember where they're positive. If they're not positive, then we know they're negative. So here's a way to remember that. All students take calculus. Yeah, what class you taking next year? Calculus, hopefully, maybe, or stats. Okay, all students take calculus, but that works better than, it wouldn't work if you said all students take stats, because it would be wrong if you did it that way. But all students take calculus is just a way to remember where they're positive. So we're going to make use of those two things together, reference angles and where trig values are positive, and I'm going to show you some examples. So here's the first example. Find the reference angles for the given angles. Now, we're not finding anything with trig values, we're just finding the reference angles. So the easiest way to do that is to know what the angle looks like. You just have to kind of identify the quadrant. So, for example, we know that this is 0, this is 180. So 145 is somewhere in here. So 145 is going to be about here. So we want to know the reference angle. We're looking for this piece. So a picture really helps. As a matter of fact, I want pictures. So we're going to take 180 degrees minus 145 degrees, and we get 35 degrees, and that's the reference angle. Remember, a reference angle has to be a positive acute angle. That it's like, what's the piece? What's the size angle that would take this to the x-axis? For 220 degrees, we're going to do the same kind of thing. And starting at 0, so starting here, and 220 is bigger than 180. And again, I don't care that it's how accurate it is, just be in the right quadrant. So if this is 220 degrees, then I know this piece right here is my reference angle. So how do I find that? Well, I'm going to take the whole 220, and I'm going to subtract 180, and I'm going to have 40, and that's my reference angle. Then on the next one, 570 degrees. Okay, well, we've got an issue here because that's bigger than 1 revolution. So the first thing I want to do is subtract 360 from this. So I get 210 degrees, and I want to find, because it's a coterminal angle, so I can use the coterminal angle. So 570 is the same, well, it's going to have the same reference angle as 210. So 210 is going to be in this in here somewhere. So that is 210. I mean, I don't care. You could do the whole little loop-de-loo to show, or you can say 210 because 210 and 570 are coterminal angles, which means they are going to have the same reference angle. So the reference angle is, to get that, I'm going to take 210 minus 180. And I get 30 degrees would be the reference angle. So that's what you do if your angle is actually larger than that. As a matter of fact, let me do one more. So we're going to have a part D. And let's do negative 280 degrees. And I want to know what the reference angle is. So 280, if this is 0, now remember the negative direction means I'm going, so here's my initial side. This time I'm rotating the other way. So this would be negative 180 would be to here. Okay. If I keep going, another 90 would be negative 270 would be up to here. I need to go a little bit more than that. So I'm talking about this angle. That would be negative 280 degrees. So I need to find this. This is my reference angle. So I'm going to take, now, you don't have to use, I can just do this. I can say it's one rotation minus, so it's 360 minus 270. So I'm not using necessarily any formula. I'm just trying to figure out what's the missing piece. So when I do that, I get, I'm sorry, should have been 28. I was going to say, wait, it can't be 90. So we end up with 80 degrees. Okay, I need to fix something right here. These are not equal. These are the reference angles. That was an improper use of an equal sign. I can use the equal sign here, but these are the reference angles. These are not the same as the angles. So yeah, I'm glad I caught that. Okay, next example, find the exact value of the trigonometric function. So these, when it says find the exact value, that means these are special triangles, or we're at least going to use the special right triangles. So this is what you're going to have to do. First thing you're going to do is draw a picture of the angle. So I'm going to, 150 is going to be in quadrant 2, because remember this is 180. So 150 starts in the positive x-axis, and so it's something like this. So here's 150 degrees. Then I'm going to find the reference angle. So I'm going to take 180 minus 150 is 30 degrees. So I have to know, what is cosine of 30 degrees? Well, so here we have 1, 2, square root of 3. So cosine of 30 degrees is going to be adjacent over hypotenuse, so we get the square root of 3 over 2. However, what quadrant is this? This is quadrant 2. All students take calculus. Sine is positive in quadrant 2, which means cosine is negative. So my answer is negative root 3 over 2. So there was a lot of math involved in that. So let me just kind of mention that again. Draw a picture of the angle. Why? Two things. So you can identify the quadrant and you'll know whether or not it's positive or negative. And also so you can find the reference angle. Then you're going to use the reference angle and make a triangle. You might want to draw triangles on your paper so you can just refer to the same ones and come up to get the value. Now you can check your answer on your calculator if you want. But here's what you're going to have to think about if you do that. If you do cosine of 150 degrees, it will not give you an exact value, and you need an exact value. But if you do negative root 3, oops, that didn't work. Well, that's okay, you can do it. You can do negative the square root of 3 over 2, and then you can show that you get the same thing. So, you know, that if you wanted to, oops, don't want to do that. Okay. Next one, sine of 240. So what do I do first? I draw a picture. Remember 180 is right here. 270 would be here because you're adding another 90. So 240 is somewhere in quadrant 3. So we'll just put it somewhere in there. And that's 240. So my reference angle is this piece here. So I find that by doing 240 minus 180. And when I do that, I get 80 degrees, right? Yeah. That does not seem right. 60 degrees, my bad. Okay, so I'm dealing with sine of 60 degrees. Notice this is quadrant 3. So if you want to right away, quadrant 3, all students take calculus. Tangent's positive, which means sine is negative. I already know my answer is going to be negative. 30, 60, 90 triangle, I need to know what is sine of 60 degrees. So you look up here, and sine is opposite over hypotenuse, so it's root 3 over 2. So my answer is negative root 3 over 2. And that would be my answer. Again, all the other stuff is the work to help me get that answer. Next one, tangent 330, draw a picture. So 330 is going to be in quadrant 4, so it's going to look like this. So we want this. So take 360 minus 330, and we get 30. That's the reference angle. So my reference angle is 30 degrees. So I need to know tangent of 30 degrees. First of all students take calculus. Cosine is positive in quadrant 4, so tangent is negative. Come over to my triangle. Opposite over adjacent is 1 over root 3, which I'm okay with that. If you rationalize the denominator, you get root 3 over 3. So negative root 3 over 3 is my answer. That's how you do problems like that. Let me do just a couple more so you know what to do if it's not sine, cosine, or tangent. So we still have to start off the same way, figuring out the angle. So if we have 225 degrees is going to be in quadrant 3. So that means this piece we can figure out by doing 225 minus 180, which gives you 45 degrees. So my reference angle is 45 degrees. It is quadrant 3. So remember that cosecant, this is the same as 1 over sine 225. And so if sine is, in quadrant 3, sine is negative, which means cosecant is negative, because when you flip something over, it still keeps the same, positive or negative sign. So we need to figure out, remember this is a 45-degree angle, so I need to know what's sine of 40, at least I usually think of it this way, sine of 45 degrees. So this is our other triangle. So we have 45, 45, 90, 1, 1, square root of 2. So sine of 45, remember, is 1 over root 2, which is the square root of 2 over 2. We want to flip that over. So don't flip this over, flip this one over. So that means cosecant of 45 degrees is square root of 2 over 1, or just the square root of 2. So that's my numerical value I need. But since quadrant 3, all students take tangent is positive, so cosecant is negative. So I get negative square root of 2. That would be my answer. Cosine of negative 135. So this time I'm just going the other direction. So it's going to be over here because it's not to 180. So my reference angle, I can do 180 minus 135 and you'll get 45 degrees. All students take calculus. So cosine is negative since tangent's positive here. So I know my answer is going to be negative. And I have to figure out cosine of 45 degrees because that's my reference angle. So it's going to be square root of 2 over 2. So I get negative root 2 over 2 for my answer. Okay? Okay, next example. Find the quadrant in which theta lies. So for this first, for part A, if you are told that sine theta is negative and cosine theta is negative. So let's think about where, if you're going through this whole idea, all students take calculus. This is what's positive. So it's positive here. So sine is positive in quadrants 1 and 2 and negative in quadrants 3 and 4. Cosine is positive in quadrant 1 and 4 and negative in quadrants 2 and 3. So where are they both negative? In quadrant 3. Okay, so this little picture will help you. Remember, this is quadrant 1, 2, 3, and 4. All students take calculus. It tells you what is positive. Now, secant, if secant is positive, then that means cosine is positive. Remember that the cosine is the reciprocal of secant. So if this is positive, then so is cosine. So cosine is positive in quadrants 1 and 4. Tangent is, we want to know where tangent's negative. Well, all students take calculus. If tangent's positive in 1 and 3, then it's negative in 2 and 4. So we're looking for the overlap. So we're talking about quadrant 4 would be our answer for that one. Okay, so I know that was a lot, the idea of the quadrants, but probably even more so this idea of the reference angles and how you can use that. The pictures, drawing the angle, using the 30, 60, 90, the 45, 45, 90 triangles, and in conjunction with the whether it's positive or negative. So that's what we're looking at. Your assignment tomorrow will cover these things. I was super nice to you and only did degrees because we could do the same exact stuff with this with radians, and we will have to do that later, but right now we're just going to focus on degrees, which is easier for you. So the assignment will be coming tomorrow. Today is just taking notes and submitting them.